America's Nuclear Darkstar Jet is ready. Here's what that means. The jet that wasn't supposed to exist. In the quiet desert winds of Nevada, something is moving. Something too fast, too quiet, and too deadly to ignore. They call it the Darkstar. No, this isn't Hollywood fiction. This is America's most secretive hypersonic aircraft, long rumored to be a myth, a decoy until now. It's real, it's operational, and it's nuclear capable. This is the jet that flies at the edge of space, shatters time zones, and can strike anywhere on Earth in under an hour. So what happens when the United States finally unleashes a Mach 6+ nuclear-capable stealth aircraft? Section 1. What is the Darkstar jet? Darkstar is believed to be a hypersonic reconnaissance and strike aircraft developed under extreme secrecy, likely by Lockheed Martin Skunk Works, the same division that gave us the State Route 71 Blackbird and the F-117 Nighthawk. Darkstar is rumored to be the real-world follow-up to the canceled State Route 72 program, a hypersonic jet that can cruise at speeds above Mach 6. That's over 4,600 miles per hour. And it's not science fiction anymore. Multiple credible sightings, defense budget hints, and contractor leaks suggest Darkstar is no longer a prototype. It's real, it's flying, and it may be nuclear capable. Section 2. Nuclear strike at Mach 6. Darkstar isn't just a recon aircraft. It's potentially equipped for nuclear delivery. Analysts speculate the aircraft may be fitted with a miniaturized hypersonic glide vehicle or tactical nuclear payload, giving the U.S. a first strike option that bypasses all known air defense systems. At Mach 6, no interceptor missile can catch it. No radar can reliably track it for long. And the time from launch to detonation could be under 30 minutes anywhere on the planet. This gives the U.S. the power to strike deeply buried command centers or mobile nuclear launchers before they can react. Section 3. Engine of the future. This isn't a normal jet engine. It's a turbine-based combined cycle, TBCC, engine that transitions from turbojet to ramjet and finally to scramjet mode, all in one flight. This engine allows the aircraft to take off from a runway like a normal plane, accelerate past Mach 1 using a turbojet, and then ignite its ramjet or scramjet for hypersonic cruise. And recent patents from Lockheed Martin reveal something even more ambitious. Plasma shielding, thermal resistance layers, and even hints at limited spaceflight capability. Yes, you heard that right. Darkstar might fly in the mesosphere, skimming space itself. Section 4. Is it stealthy? Absolutely. New materials like carbon-carbon composites, active thermal cloaking, and radar-absorbing coatings allow it to reduce its radar and infrared signature drastically. And because it flies at such high altitudes, possibly 90,000 to 100,000 feet, even detecting it is nearly impossible. This makes Darkstar the ultimate ghost. It flies faster than any missile, higher than any jet, and lower on radar than anything moving at that speed. Section 5. Darkstar and the Nuclear Triad. Currently, the U.S. nuclear triad includes land-based ICBMs, submarine-launched missiles, and strategic bombers. But each has vulnerabilities. ICBMs can be targeted on the ground. Subs can be tracked. Bombers are slow and increasingly vulnerable. Darkstar, however, breaks that model. It's fast, flexible, and mobile. It could launch from U.S. territory and hit a nuclear site deep inside China or Russia without triggering immediate retaliation, simply because the target wouldn't even know it's coming. This creates what experts call a decapitation strike option, a way to disable enemy command and control before they can retaliate. And that alone changes the balance of global nuclear power. Section 6. China and Russia are panicking. China has already tested its own hypersonic glide vehicle, the DFZF, and is working on the Jiangnan stealth bomber. Russia has the Avangard system and MiG-41, which may be its own attempt at a Darkstar equivalent. But both face one major hurdle: reliability at speed. While the U.S. has been quietly testing Darkstar-like technologies since the early 2000s, China and Russia are still grappling with guidance, targeting, and materials failure at hypersonic speeds. The Darkstar likely uses a turbine-based combined cycle, TBCC engine. At low speeds, a turbojet gets it going. As the aircraft picks up speed, airflow is redirected into a ramjet or scramjet mode, letting it fly at hypersonic velocity. And none of them have publicly demonstrated a nuclear-capable, stealth hypersonic aircraft that can operate outside a controlled test environment. Section 7. What this means for the battlefield. A carrier strike group is detected near Taiwan. Within minutes, a Darkstar takes off from Guam or Alaska, flies at 100,000 feet, Mach 6+, and neutralizes high-value targets on mainland China before they even know they were tracked. Or, in a crisis, Darkstar launches from the continental U.S., reaches Tehran, Pyongyang, or even Moscow in under an hour, and ends a conflict before the first press release hits the news. The Darkstar first entered the public imagination through speculation, defense leaks, and even Hollywood. You might have seen a fictional version in Top Gun, Maverick, but the real Darkstar is something far more secretive. Behind the scenes, aerospace giants like Lockheed Martin Skunk Works have been developing hypersonic-capable jets for decades. And among them is a design so radical, so fast, and so stealthy that even the military rarely speaks its name. That's Darkstar. That's the reality Darkstar unlocks. Its speed as a weapon, altitude as defense, and nuclear precision as deterrence. Section 8. The secret budget and shadow fleet. Buried deep in the Pentagon's black budget, an estimated $60+ billion annually is spent on programs with no public oversight. Contractors like Lockheed Martin, Northrop Grumman, and Boeing have likely been funneling billions into hypersonic and stealth propulsion systems under vague designations like Next-Gen ISR Platform or Rapid Global Strike Vehicle. And sightings of strange, triangular, fast-moving aircraft over Groom Lake, Edwards AFB, and even Diego Garcia suggest that multiple Darkstar prototypes or even a fleet could be operational. We're not talking about one jet anymore. We might be looking at an entire shadow squadron of hypersonic strike aircraft. Section 9. Strategic risks and global tension. Why? Because it increases the risk of miscalculation. If a hypersonic jet can strike a nuclear target in 20 minutes, a rival nation might feel it has less time to react and could preemptively launch its own arsenal. This compresses nuclear decision-making timelines from hours to minutes. And without a clear global treaty on hypersonic weapons, every nation will now scramble to match or counter America's capability. We are entering a new arms race, and Darkstar just fired the starter pistol. Section 10. Conclusion. Welcome to the dark era of air power. Darkstar isn't just a jet. It's a message. A weapon that bends physics, breaks deterrence theory, and redefines how global warfare is fought and ended. If it's truly operational, then we've officially entered the era of hypersonic nuclear stealth aircraft. A future where wars may be decided not by who has the most missiles, but by who strikes first and fastest. Let us know in the comments, and don't forget to like, subscribe, and stay tuned for more captivating content on our YouTube channel.